Hello dear, here we will study about the electrolysis. And before electrolysis, let's understand the or review this voltaic or galvanic cell. Basically, voltaic or galvanic cell is based on the spontaneous redox reaction. And if you remember the diagram for the voltaic and galvanic cell, so it has a electrode that is called anode on the left hand side, and oxidation half reaction occur on anode, which has a negative sign, and on the right hand side another electrode that is called cathode, which has positive sign, and reduction half reaction occur. And these two electrodes are connected with the wire, and there is a voltmeter. You can read the electron flow in the form of current, and these electrodes are dipped in electrolyte, which is boundary, and there is a salt bridge, or you can say there is a boundary between these two half reaction, that is called salt bridge. And let's see about the electrolysis now. So electrolysis is based on the non-spontaneous redox reaction. So in voltaic cell or galvanic cell, we can perform spontaneous redox reaction, but we can drive a non-spontaneous redox reaction by applying an external source of electrical energy or potential and passing through a current through the cell, and the reaction is called electrolysis. So for example, electrolysis of molten sodium chloride. And if you will see the diagram for electrolytic cell, it is almost same. There are few differences. Number one is anode is same on the left hand side, and oxidation reaction happen on the electrode, and cathode is on the right hand side, and reduction reaction happen on the cathode, but there is no salt bridge, only electrolyte will be there. And what we do, we apply external current or external voltage through a battery, because we have to perform a non-spontaneous redox reaction in this case. So there are, and the anode have positive charge and cathode has negative charge, which is totally just opposite of the voltaic cell. So this is the main difference. So three differences are there. In voltaic cell, we perform spontaneous redox reaction, anode has negative sign, and we use salt bridge. In case of electrolytic cell, we anode have negative positive sign, we perform non-spontaneous redox reaction, and there is no salt bridge. So let's see. And these electrodes are used as a inert electrode because they will not react with this electrolyte, only they help for electrolysis of molten sodium chloride. So molten sodium chloride, we will see a little bit more about this. Molten sodium chloride means take a solid sodium chloride and heat till it melt. So there is no water, only sodium and chloride. Chloride ions are there. So net reaction will happen. Sodium chloride can give you 2 sodium and plus chlorine gas. So electrolysis, if we perform electrolysis on molten sodium chloride, we can generate sodium metal and chlorine gas. And this is a reverse of spontaneous reaction. When you will apply chlorine gas on the sodium metal, you can get the sodium chloride. But here we are breaking these sodium and chlorine through applying external voltage. So you will get chlorine gas on the anode through oxidation, and liquid sodium or metal in the liquid form on the cathode through reduction reaction. So the main difference in the cathode and anode also now have the opposite charges compared to voltaic cells. Let's see electrolysis of sodium chloride solution in water. How this will happen? Can we get the sodium metal and chlorine gas as we are getting in the molten state? So here the electrolysis, we are going to perform electrolysis in the sodium chloride, but in presence of water. It means we have sodium chloride salt dissolved in the water. So in presence of water, we have to be little careful because there are two possible reactions are possible. Number one, reduction of sodium ion and reduction of water, both are possible on the cathode. So we have to find out which reduction reaction will prefer on the cathode. So how we will judge? So we have to look at the reduction potential of sodium ion and reduction potential of water. So when you will see these two reduction potential, you will see that standard reduction potential of hydrogen ion in the water is less negative, minus 0.83 compared to minus 2.71. So standard reduction potential of hydrogen ion in the water is less negative, or you can say more positive, than sodium ion. Therefore reduction of water is preferred on the cathode and hydrogen gas will generate rather than sodium metal. On the other hand, on the anode electrode, oxidation of chloride ions are possible, and also oxidation of water is also possible, but we have to find out which reaction will preferred on the anode. Then we can judge through their standard reduction potential when we will compare these two. So you will see that standard reduction potential for hydroxide ion of water is less positive, means it has plus 1.23 volt compared to plus 1.359 volt than chlorine. Therefore oxidation of water is preferred on the anode, and we will get oxygen gas rather than chlorine gas. But we can get some chlorine gas because the reduction potential of chloride ion and hydroxide ion are pretty close to each other. So if we will perform the electrolysis of sodium chloride in the water, we will not get huge amount of chlorine gas and sodium metal. We will get only hydrogen gas and oxygen gas by reduction and oxidation of water. So when you have to judge the two reactions, which will be preferred oxidation and which will be preferred reduction on the electrodes, you have to compare their standard reduction potential. And we will see next video for the application of electrolysis.